Okay, now we begin with the kinematics of simple harmonic motion. The first question. Given a simple harmonic motion, x equal to 10 sine 20 pi t, where x in meter and t in second, calculate the following values. Okay, so here we have the xt equation, and this is very important, the unit. I want you to pay close attention to the unit. Yeah, x is given in meter and time in second. Okay, now he asks for frequency. A, what's the frequency? Okay, now I write down the equation, x equal to 10 sine 20 pi t, and you must write the unit x in meter and t in second. The unit is very important. Okay, it says that this x unit is meter, means that the amplitude also meter. Same unit. Okay, the displacement is meter, so the amplitude also meter. And when the time is in second, this time is in second, that means the omega is also per second. They must have same unit. So if, let's say, if the question says that, I change a bit. If the question says that the x is in centimeter, when the x is in centimeter, so the amplitude will be also centimeter. If the time is in millisecond, then the omega, will be per millisecond. Okay, because they can be cancelled out. This unit can be cancelled out. cm cancel with cm, millisecond cancel with per millisecond. Right now, our unit is x is meter, so amplitude also meter. So time is second, so our omega is per second. Okay, so we have the xt formula. This is actually called the x versus time formula. Okay, x versus time formula, because we have x and time here. So you compare with the x time formula. Actually, I should write here. Okay, this is the x time formula we have. Okay, this is the x time formula we have, x with time. We compare with the general formula, x equal to a sine omega t. So we found out that the 10 is actually the amplitude. The amplitude is actually 10 meter. And 20 pi is the omega. Okay, 20 pi is the omega. Okay, now he asks for frequency. So frequency we can find from omega. So omega is 20 pi. Okay, and then we just apply the formula. Omega is 2 pi f. 2 pi f. So we cancel the common. Okay, so this one cut and then get 10. So frequency is 10 hertz. Okay, that's the answer for frequency. Now, what's the angular frequency? Our angular frequency is omega. Okay, we can say it is angular frequency can also be called angular velocity. Okay, angular frequency or angular velocity is the same, omega. Okay, so how to find the angular omega? Oh, sorry, that's the question C. Okay, question B is period. Period, how to do period? We already got the frequency. We can use frequency equal to 1 over period. Okay, so just do it. This 10 and this is 1 over period. So period is equal to 0.1 second. That's a period. Okay. Now the angular frequency is the omega. So omega is direct from the equation 20 pi. Omega 20 pi. Okay, so it's 20 pi radian per second. Okay, that's omega. Now, what's the maximum displacement? D, maximum displacement. Maximum displacement is actually the amplitude. Okay, we just look at the front. The maximum displacement is actually the front number, the amplitude. The maximum displacement is the amplitude. It is equal to the 10 meter. Unit, because unit x is meter, so amplitude also meter. Okay? So our amplitude is 10 meter. Here, the front. Now, what's the maximum velocity? Very simple. The formula for maximum velocity is A omega. A omega. So we already got the, oops, sorry. Now we already, okay. Now, a second. Now, maximum velocity is amplitude omega. So it's 10 times omega is 20 pi. 20 pi. It is equal to 200 pi. Velocity is meter. Sorry. So please write down the unit, meter per second. Okay, that's maximum velocity. Now, F, maximum acceleration. Very simple. The formula for maximum acceleration is A omega square. Okay. So, now, maximum acceleration is 10 omega. Omega is 20 pi. So, after we multiply, we got 4,000 pi square. Meter per second square. That's maximum acceleration. Okay, maximum acceleration. So you see the formula for maximum displacement. Maximum displacement is amplitude. Maximum velocity is A omega. Maximum acceleration is A omega square. A omega square. Very simple to remember. Now, what's the G? G, he asked for displacement at this time. At time equal to 10 seconds. So, want to find displacement at given time. So, we use equation. It gives displacement versus time. So, we need the xt equation. Okay? Because displacement with time, so xt equation. We use the xt equation. The xt equation is this one lah. Yeah, 10 sine 20 pi t. Okay, so just use this formula. And we substitute with 10 seconds. Our time is 10 seconds. Okay? Our time is 10 seconds. Remember, for this chapter, the sine, the theta must in radian. Don't use degree. In this chapter, in chapter simple harmonic motion, and mechanical wave, the theta, your calculator need to change to radian. Cannot use degree. Okay? Because why? Because we have pi. You see, we have pi. Pi is in radian, 3.14 radian, 3.142 radian. So our theta is in radian. You cannot. Your calculator must change to radian. Cannot use degree. Remember. Okay, so displacement at time. Displacement at time, that means we use the xt equation. So substitute the time inside. Substitute the time inside. So 10 sine 20 pi times the time. So what answer do we get? We get 0 meter. Oh, the displacement is 0. Okay, 0. Now, displacement at time equal to 0.33 second. How? So this one also displacement versus time. Because displacement at time. So displacement time equation again. Displacement time equation. So the equation just now. 10 sine 20 pi t. So just put in the 0.33 into the time to get the answer. Okay. So just put inside 10 sine 20 pi. The time is 0.33. Okay. Now, what's the answer? What's the answer? The answer is 9.51 meter. That is the displacement at time 0.33 second. Do you notice that this 10 is actually the amplitude or the maximum displacement. Okay, x maximum is amplitude 10 meter. Okay, x maximum is 10 meter amplitude. Okay, now the next question, velocity. Question I, velocity at time 0.33. That means I want to find velocity at given time. Velocity time equation. We need velocity time equation. So how to do we have velocity time equation? No, we only have xt equation, displacement time equation. We don't have velocity time equation, so we need to derive. We need to derive the velocity time equation. So we have the displacement time equation. So to find velocity is dx over dt. Dx over dt. So just differentiate the displacement to get velocity. So you need some mathematical knowledge about differentiation in this part. Okay, mathematical differentiation knowledge. Ask your maths lecturer how to differentiate the sine equation, sine or cosine equation. How to differentiate? Yeah. This is actually using the chain rule. You know, chain rule. So you can look up about chain rule in your maths. Differentiation knowledge. Okay, chain rule. Okay, read up on chain rule. Here I can show you how to differentiate. So to get the velocity from displacement equation, we differentiate. First, we differentiate outside, then we differentiate inside. Okay, see. Now you differentiate 10, 10 is still 10. Okay, and then you differentiate sine get cos. It's like this, you see. If I differentiate the sine, I get cos. But if I differentiate the cos, I will get negative sine. This is very important. Only you differentiate cos, you get a negative. But when you differentiate sine, no negative. Okay? From sine become cos, from cos become sine. But from cos become sine, got a negative. Remember, very important. Okay, now look at this. Again, differentiate outside, then only we differentiate inside. This is called chain rule. You know, chain rule. Differentiate outside, differentiate 10, you get 10. Differentiate sine, get cos. Okay? Differentiate sine, get cos. Differentiate sine, get cos. 20 pi t, just copy back. Copy back. Next is we differentiate inside. Differentiate inside. This is called chain rule. Differentiate inside. So we this one is part t is power 1. So that means we just take out the constant 20 pi. Differentiate 20 pi t, we get 20 pi. Okay, so multiply by 20 pi. And then the 20 pi multiply to the front. Multiply to the front, so the front become 200 pi. And then the rest is the same, cos 20 pi t. Okay, that's it. So now we got the velocity time equation. Velocity time equation. Now it's time to substitute the time. Substitute the time into the formula. Then we can get the velocity. You see that? The front here is actually the maximum velocity. Or A omega. Is it same as the maximum velocity we got just now? A omega? Yes, 200 pi. So you see that? The velocity formula, the front here is the maximum velocity A omega. This 200 pi is A omega. Okay. Now, substitute inside. Let's do it. Yeah, let's do it. So we substitute 200 pi, cos 20 pi, and then times the time 0.33. Make sure when you calculate, this one is in radian again and again and again. In radian, your theta must be in radian to get the correct answer. So what's your velocity? So your velocity is negative 194.16. meter per second. So what does it mean by the negative sign here? Negative sign of velocity means the direction downwards. Okay, the negative very important. It shows the direction downward. Now, the next question. J, what's the acceleration at this time? 0.33. Acceleration at time. So that means acceleration time equation. We need the acceleration time equation, AT equation. We don't have AT equation. So but we have velocity time equation. So we need to differentiate the velocity dvdt to get the acceleration. So the velocity equation is this one. This is the velocity equation. 200 pi cos 20 pi t. This one. Okay. So we use this one. Okay. V substitute with the equation for velocity. 200 pi cos 20 pi t. This one. Now we differentiate this one with time. Again, use the chain rule. Differentiate outside, differentiate inside. So differentiate outside. 200 pi is still 200 pi. Okay. Differentiate cos is negative sign. Don't forget your negative. Okay. Differentiate cos, you get negative sign. This one I told you just now. Differentiate cos is negative sign. Not, don't forget the negative. Differentiate cos, you get negative sign. So differentiate cos, you get negative sign. And then the rest just copy. Now differentiate inside. 200 pi t differentiate with time, we get 200 pi, 20 pi t differentiate with time, we get 20 pi. So multiply by 20 pi. This is actually a chain rule. Now the 20 pi multiply to the front, and we get the negative here put to the front. Yeah, the negative here put to the front. Okay, negative go to the front. And then 20 pi multiplied by 200 pi, we get 4,000 pi square. 4,000 pi square. This 4,000 pi square is actually the maximum acceleration, or a omega square. Is it? Is it? A max is a omega square. 4,000 pi square. 4,000 pi square. So this 4,000 pi square is the a maximum. A omega square. And then sine 20 pi t. Okay. So just remember the front here is always the maximum value. Maximum for A. This is the maximum for A. The front value here is maximum for velocity. The front value here is maximum for displacement. Okay. A omega square. Okay. Now just substitute the time. We got the answer for acceleration. Negative 4,000 pi square. Sorry. Sine 20 pi times time 0.33. And what acceleration do we get? We got the answer negative 3.75 exponent 4 meter per second square. So the negative sign here, it means what? It means downward also. Okay? It means downward. So the negative here, it means downward. Alright. Okay, now the next question. K. Acceleration when displacement is 7 meter. Oh, now you want the acceleration with displacement equation. So given the displacement, you see, given the displacement, asked to find acceleration. So we need the acceleration displacement equation. Cannot use acceleration time. Must use acceleration displacement equation. So acceleration displacement equation is the general formula. A equal to negative omega square x. Acceleration displacement equation. So we just put the x into x is 7 meter, he says. X is 7 meter. Just substitute inside. And then omega is, what is omega? 20 pi. Omega is 20 pi. Just substitute inside. So what do we get? Negative omega is 20 pi. X is 7 meter. So what do we get? We get negative 2.76 exponent 4 meter per second square. So again, negative sign means it is downward. Okay, or to the left. Yeah, or to the left. Okay, downward or to the left. Negative. It's just show the direction. So this is the acceleration when displacement is 7 meter. Yeah. Actually, he say displacement is 7 meter. Means this is actually the positive displacement. Okay. The displacement is positive. Displacement is upward or to the right. Yeah. Acceleration, displacement is positive. Acceleration is negative. You see, acceleration and displacement, they always opposite direction. They always opposite direction. So when one is positive, one must be negative. Okay, settle. Now the last question. What is the time required to moving it from the equilibrium position to a point of 8.9 meter away? So this one asks about the time. Asks about the time. And ask about the time and about the distance. So this is again xt formula. Question L is still about between time and displacement. So xt formula. But he says the time required from one position, from the equilibrium position to another position, 8.9 meter away. So this one you need to do 2 times. Okay, you need to find time for both position. Okay, first is the equilibrium position, then another time is the 8.9 meter. So okay, use the xt formula, which is 10 sine 20 pi t. So first is the equilibrium. Equilibrium is this is the equilibrium, 0 meter. So find the time. Yeah, because we want to find the time required. So we need to find the time for both position and then we minus out. Okay, so let's do it. 0 equal to 10 sine 20 pi t. And so we got our time for time 1 is equal to 0 second. Okay, 0 second. Make sure it's in radian. Yeah, don't forget this one all in radian. Yeah. Next, displacement 8.9 meter. So 8.9 meter displacement, and then 10 sine 20 pi t. So and then we calculate, and then we got the time. Yeah, anti sine, and then we will get the time 0.0175 second. This is the time at 8.9 meter displacement. So we want to find the time required from moving from equilibrium to 8.9 meter. Is the difference between these two times. So the final time minus the initial time, 0.0175 minus 0. And so the time required, time taken, is 0.0175 second. That's the time. Okay? So very simple. All you have to do is to look at what type of equation is needed. Is it xt equation? Is it velocity time equation? Is it acceleration time equation? Or is it acceleration versus displacement equation? Then we just use the appropriate formula. If we need to differentiate, we just differentiate. Okay, the appropriate formula, A versus X formula. And then the maximum displacement is A, maximum velocity is A omega, and maximum acceleration is A omega square. Okay, so and make sure you check the value first, the unit for X and unit for time. because this is very crucial. The unit wrong, you everything wrong. Okay, so see you in the second questions. Bye.